Assalamu alaikum. This video for topic 6, subtopic 6.1. Actually, it's the only subtopic in topic 6. Now, for the first question, the speed of wave depends on which factors? Actually, it depends on the medium through which it's travel. Yes, it depends, but let's continue. The amplitude has no relation with the speed. Actually, the amplitude is how loud, let's say. The energy of the wave also has no relation with the speed. The wavelength only. No, the wavelength will be affected by the speed, but it's not the only factor. Actually, it's a result, not a factor. So the medium, yes, the medium will have great effect on the speed. Now, a sound wave, it travels through a solid metal at 5,000 meters per second. This is the speed. The frequency of the wave is 1000 hertz. Calculate the wavelength. We know that velocity of the wave equal to frequency times lambda. No need to go back and see it in the formula sheet. It's used before. So wavelength equal to velocity over frequency. That means 5,000 over 1,000. That's equal to 5 meters. So this is the wavelength. Which of the following statements regarding sound waves is true? Tick all that apply. Sound waves travel faster in solids than in liquids or gases. That is right. Actually, we said, if you remember, we said in the class, whenever the density increase, the speed will increase. So more, let's say in the solid we will have greater speed. Then the liquid, the slowest is the gas. The speed of the sound change with temperature of the medium. Yes, that's right, because the temperature of the medium determine the, let's say, how fast is the velocity, is the wave, and it will have great effect also. The speed of sound does not depend on the elasticity and density of the medium. Of course, that's not right, because it depends on the density and elasticity of the medium. Okay. Next question. Which of the following properties of sound is affected by changing the frequency of the sound wave? Actually, the pitch is the, let's say, the difference between the girly sound and the manly sound. The difference between, yes, so this is the pitch. The pitch depends on the frequency, and it's C. The answer is C. Next, which of the following affects the loudness of the sound? The loudness of the sound will be affected by, I just said that before, the amplitude. The amplitude of the sound is the loudness of the sound. Next, what is Doppler effect? Actually, this is definition. It's the change, or the apparent change in frequency or wavelength due to relative motion between the source and the observer. So it's D. D is the right answer. A train moving with a speed of 30 meter per second, sounds a 150 hertz horn with frequency. What frequency is heard by the observer standing near the tracks as the train approaches? As the train approaches. Actually, VD, detector or observer, equal to Fs, I said V maybe, Fd equal Fs multiplied by V plus minus Vd or V observer, detector, over V plus minus Vs, the source. Now, which one we will use? We'll use positive or negative. Actually, we know that when it approaches, the frequency heard by the observer will be higher than the real frequency. So, since the frequency will be higher than the real frequency, I need to make sure that this friction should be greater than 1, just to increase the frequency. طيب, that means for okay, Fd equal Fs, which is 150, multiplied by V is the velocity of the sound, which is 343 according to the problem, over 343. Now, what is moving here? The object moving is the source of the sound. So Vd will be 0, so plus minus is not a big deal. For the source, in order to make this friction greater than 1, I need to subtract the speed of the source, right? So now, Fd equal 150 times 343 over 313, and the answer is 164 hertz. The same way for next question. A motorcycle approaches a stationary police car with a speed of 15 meters per second. The police car emits sound. So the police car is stationary and it emits the sound. So the source now is not moving, while the detector or the observer is moving. Calculate it. Now again, here it's also approaches. That means Fd should be greater than the source frequency. So Fd equal Fs V minus plus Vs over Vd here, and V minus plus Vs. Okay, now Fd equal the frequency of the source is 500 hertz multiplied by the velocity of the sound is 340 according to the problem. Now, again, in this case, the detector is moving. In this case here, the detector is moving. Okay. So we will, and the source is stationary. Now, in order to make this friction greater than 1, why it's greater than 1? To make sure that Fd is greater than Fs. So we will add the velocity of the observer, which is 15. So Fd D equal 522 hertz. Okay, guys, before we finish the video, I want to tell you that if the objects are going away, so let's write it here. If they are going away, so FD should be less than Fs, and in this case, I need for this formula V minus VD Vs. Now minus or plus, since FD should be less than Fs, so I need to make it less than 1. That means I will subtract the numerator VD and I will add the Vs below denominator. So this is for going away. Of course, approach or coming near, or yes, it will be the opposite. Thank you very much.